live, great. Well, hello everybody, welcome back to another game development, game engine from scratch stream. How has your day been? Mine has been pretty good. As always, just straight back from work, just had some dinner, set this stream up, and yeah, we'll continue coding on our game engine in just a second. Let's just get all the pleasantries out of the way, all the YouTube basic, I don't know how to call it, bureaucracy, that's maybe a word for it. So let me just do that. That should work, that should all be working. I just need to check if everything is up and running. It does seem so, which is also always hopeful. Yeah, YouTube is giving me the thumbs up as well. Great, thank you very much, YouTube. Yeah, I mean, everything looks good. Everything looks great. So today, what is the plan for today? I'll show you the scratchpad with the whole to-do list in a second, but as of last week and the week before and the week before, we're still cleaning up all of the code we had from the first improvement to our engine, basically rendering one triangle. We're still trying to set up the correct loop for that, the correct structure for that. And today we're going to be focusing on our model for how we're going to render a mesh. But for now we're keeping the mesh simple, it'll just be a triangle, but we're going to set it up correctly so that we can easily add another type of mesh. Well, another, basically the same mesh but have multiple instances of it. So we can hopefully by the end render two triangles. It'll be double the improvement, and then after that we can look into doing 3D, rendering a cube, and so on and so on. But I can show you in a second. I have a few full lists of how to do it properly. And just a second, but before we switch to code, do I have anything to talk about? No, I didn't touch my talking points list since last stream. Great. Okay, great. Let's. I think it's about time. Yeah, let's switch over to the coding view, the more interesting view. So let's transition. Yeah, there we go. That's all done. Let me take a sip of water. I think by the end of this you would get used to talking so much. But no, my mouth still needs my water. Okay, so plan for today. Let's clean up the render API like we did last week and the week before. How are we going to do that? We're going to create a class for all our model data, which will include all the vertex data and the shader point. That's basically this, right? Oh, I made two up. We don't need this. Oops. Yeah, there we go. So we need to set up our PSO, which will be in the shader class, which we worked on last time, which is this one. So we already have this set up. Is it correct? Who knows? But this should not do get all of these functions. This should just return a PSO, or at least we need to give our render API a set shader function or something, so we can say like switch shader to this. So that's gonna be priority number one. Other than that, we will all put all our data in a renderable class, which will take a shader, and then all of our mesh data, and eventually also some other data that we might need, like some material data, and so on and so on and so on. And then we'll make a render function. So yeah, that's, I think, the basics of it. And then we can look into all of these things, which is basically abstracting our render API. Again, making sure that we can use it if we want to switch from DirectX 12 to Vulkan or to OpenGL or whatever we want. I think that's about it. Yeah, so let's, first of all, for all the people who have not seen the state of the engine right now, let me just press the build button. I hope I didn't break anything. I hope I didn't leave it in a broken state last time. I didn't. Okay, so we still got our triangle rendering to the screen. This is all we have at the moment. Oh god. Oh. That's all we have. Just a triangle. And hopefully by the end of today, but I've been saying that for a couple of streams now, we might have a second triangle in there. So what we're gonna do, we're gonna have to go into this run function, and this has a render. I don't want this render to be in the render API. Basically what I want to do is make a list of renderables inside the application that we're going to run over during this function. So we're going to make on our application, we're going to make a private function called render. So what I like to do is split up our public or variables and our private function. So that's why I make two private clauses, and then we're going to call void render. Boop. That's going to do that. That's all of what we need. And then inside here, we're not going to do this, but we're going to do render. And in the future, we might also put an update in there, but we don't have that yet. And then we also need to get rid of this temporary bottleneck eventually. Void render. Okay, that's our implementation. And then we're going to just do in render API dot render. This is not how we're going to leave it, but this is what we're going to do for now. Because I don't want the render function on the render API. What I want on the render API is I want to... well, let's see how this render function looks now, right? So it is populated command buffer, which gets all of this stuff. This is basically what we want to do in a render function normally. And then what does it do? It doesn't execute, and then the wait for frame end. So this is still all we're gonna do. We're gonna say start recording, submit, and render. I think that's basically what we wanna do. But before we do any of that, we need our shader to be correct and our model data to also be correct. Because now what we do have is we have our shaders set up somewhere here. Basically, I think what we have now is inside our... I lost it. Where is it? Inside our application, we have like a setup here, and we do a bind shader. And then this creates the PSO and sets the PSO. That's basically what we're gonna do. But this PSO, we're gonna keep internally, because I don't think we need anything for this, except this can basically be part of the shader, I think, at least for the moment. Yeah. So we're gonna put this in the shader, and then when we bind it, we're gonna get the PSO and put it in the command list. That's basically what we're gonna do, I think. I'm not great at graphics programming, let's put it that way. So to make all of that work, what do we need? First of all, we need to move this to our shader class. So inside our shader class, we have a DirectX 12 shader. Inside here, we're gonna make a new DirectX unique pointer, and we're gonna call it, I don't know what it is. Let's see. I was open a second ago. Where's the render API? Yeah, so we need to make this object, which is this. So inside here, we're gonna make this, and we're gonna call it PSO, which is pipeline state object. I actually pipeline state object. Let's call it by the full name, so we actually know we're not limited by. Basically, if you a while back, I mean like way back, many moons ago, before my time, computer screens had a fixed size, and it was a small size. And you could only have, I think it was about 80 characters on a line, or you wouldn't be able to see it on your screen anymore. And this line over here is still representing that, and so that was basically the reason why people used like abbreviations in code and kept very short variable names. It's basically because they only had the space to put like 80 characters on the line. So that's still basically this line. And there are style guides that say if you go over this line, it's bad. I don't really care that much. As long as I can see it on my screen, so we have like 15 more characters here, I don't mind that much. Okay, pipeline state, we got this. When we load it, we're gonna go in here, we do all this, that's our element, and then inside here we're gonna make our PSO. So we're just gonna totally yoink that from this here, So we're gonna just yoink all of this, copy that, and then inside our shader, we're gonna do that as well. Shader.layout, we actually don't need that. We know our layout, which is, we can actually do get layout. Right there. Root signature, we're gonna have to find an issue with that. We're also gonna do get this. I'll do that as well. And then this is where it gets confusing, because we got all of these things correct, but then throw a field doesn't exist. Great. We also don't have a device. We don't have a root signature. So basically we want to call the render API at some point to actually make this. So what I think is a better way of doing it, I actually don't know. Do we do render API dot create shader that gives us back a shader pointer with everything filled in? That makes sense, right? But then how do we load it? Because I'm not sure. Or do we worry about that for now? I don't think we need to worry about it for now. Interesting issues here. So there's a couple of ways around it. I think the easiest is just when we get the shader, we pass the render API and that will load it, right? But I think the best way to do it is just interesting issues here. How do we make the pipeline state object? Or we can still leave the bind though, but nah, I don't think there's any issue in having multiple as long as we don't set it. And we don't set it because we give it a root signature pointer. Interesting. I didn't think I would get into issues right away. I did some research. I hope this was gonna be enough, but no. Because basically later on I want to be able to say, I don't want to load every single shader I have in my game, right? I only want to load the ones that I need for that specific scene, and even more precise for those specific visuals that are visible. Because if you think about it in the end, you're just gonna have a camera that looks at the world. Everything behind the camera you don't need to render, and if there's shaders there that you don't need to load them. So you keep I mean, how do we worry about that? Right? How do we worry about it? Because it makes sense that we just say to the render API like, hey, create this. That does make sense, but then we need to have a reference to the render API, and I don't like that. Either the shader can do everything on its own, or the shader can do nothing at all. That's basically how I want it. Right? Weird. Very weird. So let's look at the render API. What do we do here? We bind the shader, and then that makes a PSO. I only want to make this PSO once. So I don't think I can do that. What I could do, I don't know where this root signature is. That's the only annoying issue. Because all of these things we can get from the... it does make sense to go to render API to create the shader, but I don't want to load it yet. See, I want to be able to load and unload it. But this device is going to be the issue, right? We need to be able to load it there. Okay, I'm not sure. How do we make, let's go back to our application itself. How do we do it right now? We make the render API at the top. This will be hidden away at some point. Although we don't know. Because we don't know which render API we want. We're gonna have to do it like this in the end anyway. I don't like any of this either. So many choices. I do like this, the create shader. But then this does not use the render API. Right, it just creates a unique pointer from this path. And now we still need to load it. But maybe we just do render API.load shader. Like that. And then we pass it a unique pointer by const reference. That might work. It's actually a good idea. Yeah, let's do it that way. And this will apply the piezo. I think that's the best way of doing it. For now, eventually this might change again. So we're gonna make a load shader. Which gets the shader, but not by... No, it actually needs to get it by that way. Oh, that's annoying. And then cast it to that, and then we get all of this, get all of that. And then they shouldn't be that, but we should get the... We should pass it to pipeline state. So we should make a new pipeline state. So copy that. And then we're gonna make it right here. Piezo. I think that's how we do it. No, that's not. This is how we do. No, that's a temporary object. See, my issue here is we're gonna make a shader, then we're gonna go to render API, which has load shader, to then set something on the shader itself. That's weird. I'd rather have you call load shader, the shader has a reference to the render API and that will load it internally. I think that's the better way of doing it. So we get rid of this. But when we create the shader, we are gonna pass it the render API as well. So, but we won't be able to get the root signature. Oh, that's annoying. And the device. So we need to still go. Never mind, I said nothing. Oh, let's go back here. This makes the most sense. We do this, we load shader, we do that, but then we need to fill it in immediately. So we're gonna do get piezo. Do we get a piezo const reference or do we just... Oh, no, I know what we can do. We can make a direct12 unique pointer. Of this, and I think this is RF. How do I call it? HP render. What's the direct12 unique pointer? I do. Oh, it's just direct. It's not direct12. Whoopsie. Okay. So like this, we make the piezo, we pass it by reference, and then we're gonna do mshader dot set piezo, and then we're gonna do a move of the piezo. that's basically how we're gonna do. So then on what? No shader. DirectX 12 shader. Oof. That's gonna be the syntax. And then on our DirectX 12 shader, we're gonna have, not on this one, but on the DirectX 12 version, we're gonna have a set piezo, and this one is gonna take in this by right reference piezo, and then this is void, and then we can go to the CPP file. You don't need to do this, right? Maybe. We'll see. We don't need to do this. But then we call, how did we do it? What we do, we made a load shader, and that gives us a shader pointer. So we don't need to do any of this. This we can just do. So what we're gonna do is inside our render API. Oh, this is gonna be horrible. We're gonna do shader.load. First, that will set up, that will load the shader file. And now we're gonna create the piezo. Oops, okay, like so, and then we're gonna do yoink here, that there, and then we're gonna also pass the piezo to the shader. Will this be the best way of doing it? I don't know, we'll see in the future, but we have a set piezo function here, and then in this one, at the end, we're gonna do a void set piezo, and that should give me that, and then we're gonna say m.pipeline state object equals piezo. And then apparently we have not set that up yet. Oh, we did a delete copy and delete move. No, delete copy, and that's it. And then we're gonna write the move ourselves. And how we're gonna do the move? Good question. I don't know, but luckily, well, I do know, kind of. I could make it, but luckily we've already set it up right here. These two. It's basically what we need. So let's go in here, and then we're gonna yoink these two. Now we're gonna add it back to our DirectX 12 unique pointer inline file here. Oh no, maybe not at the set. Right here. Yeah. Okay. Now we're gonna copy this. Put it here, like so. HP render. Oops, that was not needed apparently. That should be DirectX 12 unique pointer. Yep. Oh, and I did not make that function call. Yeah. Oh, that's great. Hi. What would you suggest to beginner or fresher to get a job in this graphics programming industry? Either using DirectX 12, 11, OpenGL, or Vulkan. Well, basically the concepts are kind of similar in all of them. So it doesn't really matter which one you know, as long as you know the concepts. That being said though, I do think DirectX 12 or Vulkan are more industry standard than OpenGL. Right? That's, I would suggest learning DirectX 12 because it's easier. And again, if you know the concepts, it's really easy to translate between them once you understand how they work. I do know Vulkan is a little bit different than the others, but once you go around that and you know how to use it, it's probably about the same to use it as how you would use DirectX 12 or DirectX 11. Although I think DirectX 11 is getting more and more obsolete, so it should just not doing that one. So what we do here is we move the pointer, and then we set it to a no pointer. That's correct, but we need to call release on the previous object. So we need to do this. And at this point, that's fine. Oh no, that's the constructor. It doesn't matter for the constructor. For the constructor, this is perfectly okay. This one here, that makes more sense. If we already have one, we release it first, and then we set it to the correct value. We clear this, and then we return it. Okay, at this point, I think we need to make like a clear function internally. So again, I do like having my separate tabs for private variables and private functions. So let's make a clear function here, and then inside here, we're gonna add at the bottom in between here a clear function. Boom. And what is this gonna do is just this. And then we're just gonna call clear here. And then also here. Oh no, that's the one we did. Here. And here. I don't know why this is complaining. Oh, I do know why this is complaining. Don't worry about it. It's not important. Okay, so we got all of that. So why did we do that? I think it was for the shader, right? So we do this, and now we can move it. Okay, and now we'll use the move constructor. So if we check in here, it will use the copy constructor, which is wrong, because these are delete. That makes more sense. If I put delete in there, well, that was a big mistake. Glad I caught that one. And then this is moving it again, like so. What is it complaining about? It's not complaining at all. Okay, now we move it. Okay, that's that. I think that is it. So then when we create it in here, it will move it. Okay, throw a fail, that's also fine. Yeah. And then load shader. Oh, we still need to change the name from bind shader to load shader. That's not true anymore. We support more than one shader because we don't. Oops, shader. There we go. How do you manage streaming with a job? Also, do you work in the graphics industry or do you do that as passion? Good question. How do I combine this with a job? Well, I just stream after work once a week, and that's more than enough for me. I could do more. I could do less. Well, I can't really do less, but that's more than enough for me. I need to find where this shader was. Didn't I keep track of a shader? Oh no, it's bind light state object. We don't need that anymore. Okay, so how do I do it? Where do I work? I work in a game company, in a game engine. Well, not game engine, game development company. That's the word I was looking for. So I do this on a daily basis, although I'm not working in graphics. I'm working more pure low-level engine stuff. Graphics is not my forte at all. There we go. But yeah, it's just keeping track of schedule. Most of the time, if you're actually working, if you have a steady job, it's very steady hours, so you have a rigid schedule. So it's easy to work around. Okay, what was I doing? Okay, so the render API, this is gonna give issues now because we removed the pipeline state object. So wait, we need to create a command list per pipeline state? Oh no, this is initial state. Hold on, I need to check this because I'm not sure. Where's my, yes, this one. Since this is initial, does that just mean this is the initial state and we can change it later. An optional pointer, then runtime sets the initial state so that drivers don't have to deal with an event state. This overhead for this is low, particularly for command list, for which overall cost of recording command list like towards cost of single lines. So that's because of not sending. If doing so is inconvenient. For bundles, on the other hand, it might make more sense to set initial state since bundles are like a smaller value. Okay, that makes sense. So that being said, we don't need you. We can just set you to a null pointer. Great. Don't need to worry about you. And what is you? Okay, so you are again a reset, which I'm pretty sure will also just set back the initial state. Should be a reset function in here. Oh, that's too far. It's not showing, is it? No. This one. Initial state. So if this is not set, can be null. Yeah, okay, so let's put it to null actually. And on null pointer, even though they're the same. Oh, let's put it to null pointer because it's a pointer. Okay, so that's actually better than I expected. Oh, okay, so now our triangle would not be drawn correctly, I think. So if we run it, we won't have a pipeline state, so I think when we draw we'll just get an error, maybe? No, we have more issues before. Okay, what is this? Load shader? Why are you not... It's not a member of render API. I added it to render API. What do you mean it's not an... Did I not change it here? I did, right? Lock shader. No, that's not correct. This one. It seems more like... Okay. Oh. Yes, okay, so we compile. If we run, I think we will just get some kind... Oh yeah, there we go. Okay, so our triangle is gone now. Goal of today, bring back the triangle. I know why it's gone though. Okay, so what we did is in our application, we now load the shader, right? Perfectly fine. We have a shader. But now we need to actually, let's put it this way, we're not binding the pipeline state anymore. So it's when we give it our vertex data, it's just saying like, hey, I don't know how to draw it anymore. I'm not going to draw it at all. Easiest way to fix that is make this render loop. Okay, I did see another question though. So what do you expect from a fresher for entry-level role, maybe in game engine development team? Like if you're being a recruiter or looking to hire somebody in this domain? Well, it's a hard question for me to answer because I'm still entry level as well. Finding Nemo, not finding triangle. Yeah, exactly. It's well, I know where the triangle went. It's just not drawing. How to answer your question though? So, as a game developer, as a like engine programmer or graphics programmer, because those two are like kind of like synonyms, but a little bit different. They're both very low level in the game engine or in the game development process. I would say, especially since game development is such a C++ oriented field, or at least like C++, or if you're working with Unity, it's C#, but then you're not really doing engine development. But like Unreal, making a custom engine, I don't know, Godot uses GD script, I don't know what that is about, but then again, that's not engine programming. So most engines are written in C++, so very broad basics, well, a very good basic understanding of C++ knowledge is a good one to have, like at least know a little bit about the standard library, how to use some generic programming, like using templates. And then the biggest one, the one they most certainly are gonna ask on an interview, is the difference between a stack and a heap. If you know that one, really good. That's like the basic understanding of how C++ works. If you know the answer to that question, I mean, together with some basic knowledge, and some maybe some design patterns, but that's not really needed. You can learn it on the job. That's it. And also, don't be scared to say you don't know something. It's better to say you don't know something than to give a stab at it, be completely wrong, and they're gonna tell you no, you're completely wrong, and it'll give a bad impression. But that's about it. So, triangle. How are we gonna get the triangle back? Well, we need to set the shader correctly. So to do that, I don't want to make anything bad at the moment. So we're gonna do, basically we're gonna make a renderable list, which will have a shader link to it and some vertex data, and then the shader will, and then we're gonna be able to call render on that, or something similar, which will use the render API to render to the screen. I think that's how we're gonna do it. Kind of. But we're gonna do that very simple at the beginning. So we're gonna make a command list. I think that's the next step. If you go back to our a to-do list here, I don't know if this has any order to it, but we set up the PSO, did that, and now it says create renderable class. I'm gonna wait with that. I'm gonna make the command list first. So let's put that at the top, because that's what we're gonna use to draw our triangle again, and I think it's better if we actually have a triangle to test things out. So right now, inside this file, inside this class, we have this, a command list, or a command queue, or whatever. I think both, all of these. We're gonna make our own render command list, which will be a wrapper struct where we can say we're gonna push commands to it, pull commands to it. Yeah, fully blown 3D game engine. It is very ambitious, but that is the goal. And the goal goes even a little bit further than that. It's gonna be making a game with that game engine, because you can only show how good your engine is when you actually make a game with it. I mean, there's a lot of theoretical examples of an engine, but if they're not usable, or I mean, you need to show how to use the engine, right? And making a game with that it's logical. So that's what we're gonna do in the end. What that game is gonna be, who knows? I don't know either. But yeah, it's a very ambitious project, I know. Okay. Render command list. This is gonna be internal to, I think, every single graphics API, so we are going to add that to our folder here. So inside our render API, we're just gonna put a generic file, which, why did I make a publisher document? That's wrong. Okay, so we're gonna make a render, let's call it actually a command buffer, because that's more correct. .h. Or no, is it a list or is it a buffer? Let's keep it with list. I think it's actually more a queue, but that's fine. So we're gonna do that, and then inside the DirectX 12 one, we're gonna also do that. I opened the file in Microsoft Visual Studio Code. That's not it's not great. Okay, I don't want this. Just move. It's opening it again. No. Thank God that's all on the second screen. Okay, change the name. DirectX 12 in front. Oops. 12, not 21, 12. There we go. And then copy this again and make a CPP file. Boom. Okay. And then that's that. Inside our CMake list here, we're gonna add our RS. So here, render command list, and then we're gonna copy that, place it in here as well, but do this. That makes more sense. And then .cpp save. We're gonna have, oh, I should have upgraded, god damn it. Oh, distributed rebuild. They have a new version of Rider, which is the IDE I'm using, and apparently it's a lot better to work with CMake and C++ game engines. Because previously the version I have is mainly focused on Unreal Engine. but not like C++ projects on their own. They actually have C-line for that, which is a different IDE. But I like this one, and it does work with C++. It just didn't have everything. But I should definitely update at some point. Okay, so we got our files now. I think they're in here. Yeah, we got a render command list, which is just a full empty file of random publisher stuff. Don't show this again. Oh no, I don't know what was in there. It was just a bunch of, okay, yeah, it's a bunch of crap, probably because I selected publisher document and it made an empty one. Whoops. Okay, so we're gonna make pragma once, and then we're gonna make a namespace. We're gonna call it HP render, which is my rendering namespace. Apparently it added these twice, great. And inside there, we're gonna make a class render command list. That's all we're doing here for the moment, I think. And then we are going to go in this one. We're gonna pragma once again, but we're also gonna include that render command list file. And then inside our namespace HP, did I make a separate one for DirectX 12? I don't think I did. No, I didn't. Okay, that might come and bite me back in the, well, I might have shot myself in the foot there. Either way, making a render namespace again, and then we're gonna do class DirectX 12. Did I call them DirectX 12 or just DirectX 12? DirectX 12. DirectX, that's bad. And this is, does it say? No, this is just render API. Okay, so a little bit of a naming convention issue. I will fix it in a second. I'll do everything with DirectX 12 and then render command list like so, and then we're going to publicly inherit from normal render command list. No, not that one, just a normal render command list. Like so, which should be, did I spell it wrong? Is that the issue? Oh no, this file reset. What? Where did I? Oh, whoops, I put it in the CPP file. That's completely wrong. Okay, that's better. Huh, okay. A little bit worried there. Okay, that's it. So now we inherit from this. It's gonna be all perfectly fine. Before we do anything else, we're gonna do a rename. Find in files. Can I do a replace? Is this a replace? That's new line. Where's the replace button? Okay, not in here. Is it control find? Not this one. Find replace. Where's the find and replace button? Edit. Find. Control H is find and replace. That's weird. Okay, and then we're gonna change all of these by DirectX 12 underscore unique pointer. And we're gonna replace all of them, but we're gonna do probably Control Shift H. Ah, yeah, that's the one. And that, and then we're gonna do replace all. Yes. Whew, boom, done. Great. Okay. Now we're gonna make our render command list. First of all, I don't know what actually needs to be in here, but we will need a public and a private eventually. So let's put that in there as already. Actually, let's go to the shader implementation here. And we're gonna do kind of the same here as well. So inside public, we're gonna do that. We're gonna copy this, paste it over here. override. Yeah, I think this can be empty, so let's just do that, and then we will make it in a second. Delete, copy, and move. We need to import. Just on it there. There we go. Then we need that one as well. And on inside our normal one, we're gonna need to make a render command list. What? No! Which will just be that, which equals default. So that's a not delete, default. It's our default constructor, and then we're gonna need to make a render command lists, but we're gonna need to make it virtual. There we go. And then inside this one, we actually don't need to override it. I don't like the overrides, but we need to make it final. And then default is definitely not an option. Oh no, actually it is an option. So let's do default. And then this one will also do default for the moment. But then that does mean I actually have override here, which I don't really like doing. Final. I need some kind of linter in the end. Render API, this is also final. Yeah, that's fine. Yeah, okay, the rest is okay. Window, this is also virtual. Okay, and then we have another window in Win32, so let's mark that one as not override either. There we go. Makes more sense. Render command list, done is a big word, but set up at least a little bit. And then this is pure garbage, so let's just include that, and then let's do render command list. Okay, so this is our constructor, and then in here we're gonna make our render command list, which I'm pretty sure is just in render API at the moment. So let's figure out how to do that properly. Initialize, yada yada yada. Where's our render command list? Describe and create the command queue here, and then do we create a command list? Where do we create the command list? Frame resources, create command allocator. Jesus, root signature. Where's the command list? Here? Only in load assets? So what is the command queue used for? Because if we don't need it, we don't need it. And then we can just do that. What's the difference? What? Do we need separate command allocators for separate command lists? Let's actually go to the command allocator. Parents allocation of story. Okay. Must use a command allocator. Okay, so I don't think we actually need to create any more command allocators or command queues. We just need one, but thread, it seems like, which is fine. We're still doing single thread at the moment. And then for what do I need the command queue? Because I probably also need to pass that. What's the command queue used for? Huh. There's so many things here. Command queue. Here. Which will be used to execute command list. So that's all fine. We don't need to worry about that. So we just need to store. Now we signal the command queue here. Okay, so we don't need to worry about all of that. We just need to create a command list, which we do with this single line over here. So yeah, we're just gonna do both of these things in the constructor. But this will be a little bit trickier because we need the, what am I doing? We need the render API to create a command list. Right? So what I think we're gonna do is, how do we do this properly? So basically this will store the unique pointer to that, and then we're gonna just render API and then command list. Is that an option? I guess I can just store it with a wrapper function. So basically what I can do here is on a render API is we have load shader here. What we're gonna do is we're gonna have a create function here, which will return a render command list, but not just a normal one. Or will it just be a normal one? No, it will just be a normal one. It will be copied over, but that's fine. This is gonna be tricky. Now we're gonna do create render command list. You don't pass anything, that's all fine. And this is a virtual function. No, this doesn't need to be a virtual function. Inside here, at the bottom, I'll just put it at the bottom. We do a, well, just void render create render command list. Oh, this is gonna be the annoying issue that's not the same file name, so it doesn't know what to do. So let's just copy that all the way and then do that, and then do this on here, do that render API. There we go. And now it knows it's a function call. Okay. Got all of this. And then we're gonna create a render command list, which we do like so. Wait, where is it? Like so. Yoink this. Copy. Paste it here. Do that. We're not gonna store it in command list though. We are gonna create how we're gonna do this? Oh yeah, we're gonna do it the same way as this one. So we're gonna do that. Boop, and then we're gonna do another command list. That, and then this should be render command list, but I don't know which one that's gonna be. So how do we call this? This. Like so. We store it, we put it in there, and then we're gonna set it on the object. Start it off recording. We need it closed. Start closed. Okay. Yoink that, do that, and then we're gonna do return dirx12 render command list. Oh, disable my numlock, render command list. And then we're gonna just pass it this in the constructor. And let's hope that works. So inside this one, we're gonna pass it DirectX 12. No, that's not the one we need. We need to do the, oh no. This one. we need that one. Inside here. Boop. Oh, we need to include this? Oh, it's gonna be ugly. I'll enter, yeah, it's fine. Oh no, we need to... Oh. See, the issue with all of these things is that we need to do all of this ugly stuff. Because they have... I need to find a better way of doing that. There. That should be all of that done. And then we're gonna do... That makes sense, right? Did I miss something? Did I copy something too much? No, this is all fine. That, and then we're gonna do twice, and then render command list like that. We need to include this as well, like so. This is default, which is fine. Doesn't make sense. And then we're gonna store this. And render command list like so. And then in here we're gonna just set pressing the wrong buttons again. Reference render command lists, and then in here we're gonna set render command list to that. Not mrcl, render command list. There we go. Hey, what? Oh, and we need to do the base. Yeah, that makes sense. Not like that, like so. Jesus, that's getting hard. Okay, and then this is complaining about something. No, it's not. Never mind. Boom, done. We made a render command list. Oof, Jesus, okay. So then, instead of in the render API creating the render command list like that, in load assets, wherever that was, command allocator, this one, we're just gonna call create render command list. And then for now, we're gonna set m.render command list equal to create render command list. There we go. And then this one doesn't need to be that anymore, but just an HP render command list pointer, I think. It needs to be a pointer. It needs to be a pointer, doesn't it? Oh, shoot. It does need to be a pointer. So we're gonna do HP unique pointer. Pointer of this type. And then inside this is gonna read a pointer. Why does it need to be a pointer? Well, actually, let's just return it. This anyway. There we go. Like so. I think that's okay. Maybe. At the bottom here, we're gonna make it turn. I know where this is. Let's see where in our application we made like these. Did we not make it in application? Oh, it's probably in Engine Core. We make like this creation helpers. Okay, so we need to do this. And then inside render API. Boop. And then this, and then like so. And this is not in command list, this is shell. Close. Okay. And then we return a unique pointer. Okay, and then whoop. And here we do. We create the command list here. We don't need to close it here, so we can close that. Okay. Oh boy, this is getting way harder than I expected. Okay, so execute command list is not get raw, but oh no. We'll need to finish them. And we don't need this, but we're gonna say dot execute maybe. And then we need to reset them, and then we need to do all of these things. Oh boy. Oh boy. Holy. Oh, something. Interesting. So the close and the reset. Now we calculate populate command. Huh. So the resource barrier, I don't know how we're gonna do that. That's a pointer though. That's interesting. It's weird that this can be just a pointer. That this doesn't need to be a pointer. Oof. It's getting complicated again. Why is it always so complicated? I thought this was gonna be the easy one, but now we need to record everything. So the populate is where we get all the commands, and then we're gonna finish it here. Actually, we already finished it here, which is called close. And then you will call reset on it, which gets, we need to pass the command allocator to that. Oh, it's gonna be annoying. What if we don't put the command allocator in here? Reset. Pointer to the object that the device creates command lists from. Okay, so we do need that one. Oh boy. Okay. We need a plan of attack, or whatever we want to call it. Basically what I see is that our render command list should not only have this, but it should also have a pointer to the command allocator. The issue with that is this does not store the command allocator. I don't want to ref count it, that's gonna be stupid. So are we just gonna put a straight up pointer in here? We might as well too, so I'm checking why we wouldn't do it. Okay, let's just actually check the command allocator. Present allocation, method stat, remarks used to create command allocator object. Command allocator corresponds to the underlying application in which GPU commands are stored. The command allocator object applies to both direct command lists and bundles. You must use a command allocator object. Any more information? No. Great. Examples it is. Okay, direct 12. It's pure Googling time this time. Multiple command allocators. It has the immediate mode of previous versions and instead apps create command lists and bundles to record. The command queues are to submit command lists to be executed. The model allows the developers to have more efficient control. Yeah. Command queue. DirectX 12 command queues replace runtime and drivers of immediate mode. Documentation time again. Okay, allows command queues can be created. This method takes a command list type indicating what type of should be, and therefore what type of commands can be submitted to. Many bundles can only be called from direct command queues and can't be submitted to it directly to a queue. In general, direct queues and command lists accept any command. Compute queues and command lists accept any compute commands. And copy queues. Okay. And either retrieves a default command queue or create a new one. You execute command list by calling that. Applications can submit command list to any command queue from multiple tabs. The runtime will perform the work of serializing the request and order submission. The runtime will validate the submitted command list and will drop the call to execute if any of restrictions are violated. Calls will be dropped for the following reasons. Oh, we can only call reset at the beginning? Jesus. Before and after states of queries. There are a couple of rules imposed on the runtime that restrain actions. And resource cannot be written to from multiple command queues simultaneously. When a resource has transitioned to writable state on a queue, it's considered exclusively owned by that queue and must transition to read state or common state, referred to So also means that app needs to explicitly manage synchronization work, especially when the command lists in one queue depend on the resources that are being operated by another. Some examples of a wait on operation on compute queue complete so that we can blah blah blah. Okay. Which is a fence. Oh boy, this render command queue is gonna be a lot more. And then resource barriers are used to sync resources. Okay. Oh boy. So I know we already have a fence somewhere. I don't know why we actually use it, but the fence is in here, right? Because we have a fence somewhere here. Wait for frame. We signal here, and that's the fence. And then we also have a fence here. It's creating the fence. Oh. Waiting for frame completion. Let's go with it. Okay, we will fix that later on, but we do a command queue signal. My question here is, do I need multiple command queues or not? I don't know. because we have a command list, right? That's the one we made. The question here is a command queue. Do we actually, if we make a command queue, do we only make one, or do we make one per thread, or do we make as many as the command list we have? How many command lists should there be? That's a good question. Basic render loop is one, the command queue, one allocated per back buffer swap chain. Do we even have multiple allocate? What? Do we have multiple command allocators? We only have one. Okay, so let's keep one queue, one allocator. I don't know this. We have multiple lists here, that makes sense. A given allocator can be associated no more than one currently recording command list at a time, though one command line can be used to create any number of graphic command lists. Okay, so we need to make an allocator per command list, I think. So we're gonna put the allocator in there. This is what it says, right? Yeah. Command allocator is create command allocator. When creating a command list, the command list type of the allocator specified by that must match the type of the command list being created. A given allocator can be associated with no more than one currently recording command list at the time. So I would say one command list has one allocator. To reclaim a memory allocated by command allocator, app calls reset. This allows the allocator to be used for new commands but won't reduce the underlying size. But before doing so, the app must make sure that the GPO. Okay, so if we check back in our code currently, we have command lists. We clear the command allocator and then we also reset the command list. So I'm pretty sure we can just move the allocator to our render command list as well. That way, I don't think, where do we actually use this? Because we create it here. How do we create it? Just on the device, so we can just do it at the same time. I don't think we use the command allocator anywhere in here. And then here we just reset it, right? So then here we create it. Okay, so what we could do, and what we probably should do, is make a command allocator here, and also make a command list. Let's give them a little bit more readable names. And then we create one by moving this and also moving the allocator that created it. Like so, and then the allocator here at the top, we are gonna make a yoinksy here. Make that at the bottom here as well, right here. And then create command list here. Create command, the command list here. I don't know if this is better practice or not, right? This is me just struggling with things. thinking it's this. I guessed correctly. Okay, and then inside of this one, we're gonna also put a unique pointer to our allocator. It will be a command allocator, like so. And then we're also gonna have, I'm gonna put this one here though. Allocator. There we go. Okay, struggling done. We made it here, we made it there. Render API made it as well, and then we can also get rid of the, oh, that doesn't work, command allocator here, which is you. We will still keep the command queue because I think we still need it, unfortunately, but we have the command list here. Will I complain anywhere else? Okay, yeah, and then we're gonna make a reset function. All these we're not gonna worry about for now. And then a finish or close, or yeah. And then we still need on the command queue to actually submit it. Yeah. And where do we submit it to? To the command queue. So we should probably also make some kind of executor. So then we didn't. Yeah, maybe. First things first, we can make a reset. So we're gonna make, oh, it should be public. And then also don't like that this is all not indented. So indent yourself. And then we're gonna make, oh, this is just, there we go. That's still weird. It's like not indented correctly. And it's bothering me. There we go. Okay, is that better? That's correcter, I think. Void reset. There we go. And this is to implement yourself. Oh, and it's to be virtual. And then this one will complain because we didn't do void reset override. There we go. No, rest reset. There we go. And then inside here we do void reset. What are you complaining about now? Oh, yeah, we need to do command allocator and then move like that, and then you copy this. Remember when I talked about space? Like so. And then we also need to copy that and do that. Should be it, right? And I probably messed something up somewhere. Oh, I have a bracket here. I don't need a bracket. Yeah. There we go. Okay. I saw that. Now, how do we reset? We go to our command allocator, press reset, and then we're gonna also go to a render command list and also do reset. I think in here we need to pass our command allocator. Don't get raw. And then a null pointer, which is our initial PSO state, which we don't have. So this is all we need. Okay, render command list done. Well, the setup here at least. So we got the reset figured out. So now we should be able to do, oh, we should be able to do throw it failed as well, but that's fine. So let's just do command list dot reset. Nice. I think it's the only place where reset is called. We still have all of these things to worry about. Also this one, which is gonna be interesting. Will be a submit. And that's, yeah, okay, that's all those things. All of these things, not too happy about. Oh. Okay. So what this one says is, oh, we're actually only gonna have one command list, I guess. Because we're all saying we're gonna draw to the render command buffer. Maybe if you make different passes in the future, that will work. Who knows? Who knows, indeed. Okay, so that's all that. This will be replaced by your other thing, so we don't need to worry about that too much at the moment. So what do we need to do? We need to create a resource barrier, but that's one that says... Oh boy. I shouldn't have started with the render command list, I guess. So this is basic things we need to set up, which is our viewport setup. But that means, oh my god, we need to set up all of these things as well in the command list. Oh no. Oh boy. Oh, Jesus, this is gonna be annoying. Indicate that the back buffer will be the render target. This is that. And we set that to the... Yeah. And then we set the render target. We're gonna switch from present to render target, yeah. Oh boy. Hello, welcome. I'm struggling with graphics programming. Join me, help me. I kind of know what to do. We can call close as well. I do think we have 2 closes to worry about. Oh no, we only have 1 at the moment, but I'll call it finish. Alright, so we're making a finish. That's the easy one. So do this and then call finish. Right here, and then inside here we also gonna do this. Call finish. That's the easy one. And then we're gonna just call void finish. And do command list close. There we go. How are you so smart? No, don't. You see all of this red? That's what I'll still need to fix, and I don't know. I don't have any clue how yet. So not smart at all at the moment. I even broke my engine, so we don't have a triangle to look at the moment. This is a draw mesh. Kind of understandable. Oh, the clear should probably be up here. Oh no, wait, hold on. The clear we also always need to do every single frame, right? And then after this is our custom command, and then at the end we also do this. So we kind of need to do all of these things independent on if we actually need to do anything or not. No Google, no. Yes Google, no AI. Without Google and documentation, this would be impossible for me to do. Don't see, not that smart. I still use lifelines. Okay, so this I mean, this is just setup, but we need to get it in a way that makes sense. The root signature, I'm not so sure how to do that one. Is that part of a render view? Is that not? I don't know. This kind of does make sense. Oh, resource barriers, that makes sense. But we can't do this way. We need to abstract it, which is annoying. Okay. How long have I been doing this? I've been doing this for, I think, a couple months now, maybe 2 months, 2.5 months, something like that. I'm trying to make a game engine from scratch. At the moment, when it's not broken, I have one triangle. That's all I'm drawing at the minute. One single triangle. It took me so long. Okay. So this is all also makes sense. I need to wrap that as well. Oh, it's so annoying. I wanted to get rid of that. You know, let's make a hack. Let's make a hack for now, because I want to make it work. Maybe. Maybe. Oh, it's gonna be horrible. If I make a hack now, I think I will not make it proper in the future. Not 100% sure how to do it properly, but the finish, 100% correct. The finish and the reset at the top, that makes sense. We reset at the start and then finish at the end. But then we need to set up our render target. So we're gonna have to do set render target. And then we're gonna have to pass the render target. So I'm gonna have to make a render. Oh my god, this is gonna be horrible. Oh boy. Oh boy. So basically, to get the triangle to work, it took me 2 streams. So that's about 4.5 hours, 5 hours. But then since then, I've been trying to make it a little bit more pretty, a little bit more structured, so that we have a nice little code base to start working from. It's not there yet. The only issue we still have left is this class, this massive file. And we will need to move things out of it bit by bit, piece by piece, and that's what I'm doing now. So we're gonna have to submit it to the command queue as well. Oh, and I have to make a command queue. Oh my god, this is horrible. But these things I don't know how to do, how I will do. This is gonna be horrible. The barriers as well, the set resource target, I'm not sure how to do that properly. These things, easy. This will just be a draw mesh function. We'll do all of this. The rest though, I'm not so sure about. But we can't forget to also set the PSO. So actually, let's do some pseudocode in here. Set PSO. So we don't forget. I'm so confused. Well, not confused. I'm not sure how to do it properly. Because basically we want to make a transition barrier, right? Which is all of this crap. So we want this to be correct. And then we can pass that in here. And then we're gonna have to pass the barrier. But do we want to do that? Probably. I'm not sure how to do this properly. I need to think about this. This command queue, it's gonna be hard to do properly. Because I want to make it independent of DirectX 12. But right now it's very tight to it, because all these commands are specifically for DirectX 12. So basically what I want to do is say command list bind render target, command list clear render target, probably. These I think I will always need to do. Not sure actually. And then if we want to bind the render target, we first need to make a transition barrier. And then we also need to release the render target again. Oh boy. Oh boy. I'm at a loss at the moment. I was so prepared. Let's look at the command list. That's a command allocator. Where's the command list? So we have create command list, and that will create as a command list. So let's go this one, and this will return a command list in the end. This one, graphics command list. What kind of method has this? Begin event, begin query, clear, clear, clear. A lot of clears, a lot of. We need to have function calls for all of these things. Execute a bundle, that might be a useful one actually. But no. Sets the view for an index buffer. Vertex buffer. This is all the shader stuff. See, it keeps going. Bind the area of scissors, bind the area of that. It keeps just going. Set the constants in the compute shader. I'm guessing we also can do set graphics roots shader, root constants, set graphics root constant buffer, so we fill things in. Root signature, yeah. So we're always gonna have to do the root signature. We're always gonna have to set up the other things as well. But boy, is it annoying to do. Whoops. Yeah. So we reset command list can only be reset when the associated command list have finished execution. Abstract fences determine the execution process. Yeah. So we get the allocator with the frame index, we reset it. And then we reset it here as well. See, they make a command allocator per frame index, which is smart. I didn't do that. So basically we can make a command list per render target maybe. Oh boy. And now we set the PSO, we set the root signature. They set the descriptor heap, they set some stuff. And then we set the resource barrier so that we know that it's used as a transition barrier. Can we actually check the rest of this code? Oh, we can. Okay, so they just do a bunch of stuff there. Then they set the render target. Apparently that needs to happen before we set the render target. Great. And then they clear it, and then they're gonna render some stuff here. Then they set the viewport here as well, which is late because the scissor rectangle they did at the top, right? They didn't set the scissor rectangle. Don't they have one? They do. Where did they set it? Oh, they do set it here. Okay. I would do it at the bottom here as well. And then they present it. Whew. So they all have the kind of the same logic to it, but I don't know how to do it properly. Oh boy. See, because I kind of have the same flow, right? We set some state here. Ooh, that was a big lag spike. Set some state here. We set a research barrier because we're gonna say that we write a render target. And then we clear the render target. And then we write our shader. We write our triangle. This is basically our triangle, by the way. And then we say we need to present it again. That's it. It's gonna be hard. I don't know for sure how to do it properly. I think the best way to do it is by having... I'm not sure how to do it. If we were gonna do it by render target or not, because then we could technically say we're gonna render the render target. So we're gonna say start on the render target. It will give us back the command buffer after it already initialized like all of this, did all of this, cleared it and everything. Then we can do our own code, and then afterwards we can do this. That's one way of going about it. I'm not sure if that's the correct way of doing it, or if the best way. It's more like it. I think, honestly, I need to do more research. I don't want to bore all of you people with it. So I think the best way to go about it is I will end the stream early this week, do a bunch of research on command lists. Again, expand or ever expanding scratchpad of how everything we still need to do in here. So we're gonna do create command list. I'm gonna add some points in here that say exactly what we're gonna do next stream. If that is correct, I think a renderable class I can pretty much already do with the research I have. The barrier and fence class we're probably gonna have to make beforehand, as well as the render target one. Did I make one for render target? Maybe not. But basically, I need to do a lot more research on how to properly do this. Look at the example codes and stuff. I don't want to bore you with it. It will take hours. So I will end the stream early today. I know it's shorter than usual, but honestly, I mean, it would be staring at documentation, me being silently reading things. It's not that interesting to watch. So I am sorry for it, but it will be an early end to the stream. Hope you enjoyed it. If you did, next week you can see if we actually figured out how to do it. And then we can implement it together. Same time, by the way, if you want. But yeah, that's about it. I will try and find the... Yep, that's the end stream button right there. So that's about it. If you... yeah, I just hope you have a great rest of your day, evening, morning, afternoon. I don't know. I don't care. Just have a wonderful rest of your day. And I'll see you next time if you decide to join. Goodbye.